This is Precalculus, Functions and Graphs. I'm Mr. Stark. Thanks for joining me. We're on topic 1, which is titled Modeling and Equation Solving, and this is lesson 1b, Problem Solving and Grapher Failure. We'll learn about the quadratic formula, connecting zeros, roots, and intercepts, a 4-step problem solving approach, as well as an example of grapher failure. You can follow along using this document. Just take some notes. Let's get started. The quadratic formula is the first thing I want to show you. In order to use the quadratic formula, the equation we're trying to solve has to be in standard form. The standard form of a quadratic is ax squared plus bx plus c is equal to 0. A, b, and c are real numbers that we use in the quadratic formula, which is x equals the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. When the formula is simplified properly, it gives you the exact answers. Let's apply the formula to an equation that we solved in the last video by factoring, which, by the way, is the best first step in solving equations. See if you could factor it first. Here's the equation, which is already in standard form. X squared minus 3x minus 4 is equal to 0. Notice that a is 1, b is negative 3, and c is negative 4. So we plug it in the formula to get this expression. We have 9 minus the square root of negative 16, which is the same as 9 plus 16, which is 25. So we have 3 plus or minus the square root of 25 divided by 2. It just so happens that 25 is a perfect square, but if it's not a perfect square, then we would either leave it as it is, such as the square root of 65, or we would factor out a perfect square to simplify that radical. In this case, our two answers are 3 plus 5 over 2, which is 4, and 3 minus 5 over 2, which is negative 1. And those just happen to be the two solutions we found last time. Now let's make some connections between zeros, roots, and intercepts. Many times these three words are used interchangeably, but they have specific meanings. So let's use the example f of x equals x squared minus 4. And if we solve that, we get x squared minus 4 is equal to 0, x squared is equal to 4, therefore x is equal to positive or negative 2. Those answers, positive and negative 2, mean three different things. Number 1, positive and negative 2 are roots of the equation. Think about it like a tree. Those roots provide a structure to that equation. Number 2, positive and negative 2 are zeros of f of x. If you plug them into the function as x, the function is equal to 0. Number 3, positive and negative 2 are x-intercepts of the graph. When we graph the function, the curve intersects the x-axis at positive and negative 2. Problem solving can be messy. Here's an approach that can help you be more efficient and learn from your mistakes. There are 4 steps. The first step is understand the problem. Read the entire situation and make sure you understand what is actually going on. Step 2, devise a plan. Think about the steps that you'll take and how to organize your work. Step 3, carry out the plan. So do the problem and don't get distracted. But if you do, come back to it. Finally, step 4, look back. Reflect on your work, learn from it, and see if there's a better way to do it next time. The last thing I want to share with you is an example of grapher failure. It applies to the TI-84 graphing calculator. And I'm pretty sure it happens on all of those models, the TI-84, TI-84 Plus, TI-84 Plus Silver, TI-84 Plus C, and the CE edition. The C and the CE are the color versions. We'll use the rational function 3 divided by 2x minus 5 and enter that into y1. After that, I press zoom 6 to give me a standard viewing window. What I see is a function that has two parts, kind of like a left side of the function that's curvy and a right side of the function that's curvy. And it looks like something special is happening between 2 and 3. To see the grapher failure, I press second zoom for the format menu, and I arrow down to detect asymptotes. Mine is currently set to on, so I'm going to arrow right, press enter on off, then press zoom 6 again. I could have just pressed graph. Now what I see is a diagonal line that looks like it connects the bottom part of the left curve to the top part of the right curve. And if I didn't know what I was doing, I would think that there's an x-intercept somewhere between that 2 and 3 I talked about a moment ago. That's a fail. And if we said that x equals 2.5 was a zero of the function, that is also a fail. When in fact, x equals 2.5 is a vertical asymptote of the function. It's a line that the curve is approaching. What? That's a fail. Okay. Oh, hey, I didn't even know you were still there. I was just doing some calculations and stuff. That's really the end of the video, so I hope you learned something. See you next time.